Good morning, good afternoon, and good evening. Thank you for joining Tekton Day on Google Open Source Live. If you haven't attended Open Source Live before, it's a monthly web series where each month we explore a different topic within open source. Today, of course, is all about Tekton. My name is Divya Mukherjee, and I'm a software engineer at Google and currently a maintainer for the Tekton project.
Thank you, Divyo. What's up, everyone? My name is John, TPM at Google. Divyo, can you please tell our open source friends what fun stuff we have planned for them
Of
today?
course, we have some really interesting topics in store for you today. To start off, David Bendori and Christy Warwick will be leading a session focused on supply chain security with Tekton.
Okay, friends, don't forget to put your questions in the live Q&A forum below the live stream window. Speakers will answer your questions live, and they'll get to as many as they can in the time allotted. Pro tip, if you're viewing in full screen mode, you'll have to exit out of full screen mode to see the live Q&A forum. Our sessions have been pre-recorded to allow for accurate transcripts and so that speakers can focus on answering your questions live. Once we're done, don't forget to join us at the after party. You'll see a button to join at the bottom of the events page after the last session. And remember, use Google OS Live hashtag to share your experience on social media. All right, let's dive right into it.
Hi, I'm David Bendori. I'm the engineering manager for Tekton. I have been at Google since 2015, and today I'm here to talk with you about binary authorization for Borg. This is an internal system that we use at Google to verify code provenance and to implement code identity. And presenting today alongside me will be my colleague, Christy Warwick. Christy, do you want to introduce yourself?
Sure. Hi, everybody. I'm Christy Warwick. I'm a software engineer at Google where I lead Tekton and Secure CI/CD.
So we're going to start the presentation with me focusing mostly on Google's internal processes. I will then turn the floor over to Christy, who will talk about similar tools for Tekton and open source. Then we'll come back to me. I'll provide a demo of binary authorization running on Google Cloud Platform itself. Google has released a white paper on binary authorization for Borg, in which we describe Google's code review process and the way we gather provenance and the need for enforcement mechanisms. And that's really what I'm going to be talking about today. So the context we're talking about here is minimizing insider risk. And our goal is to prevent a nefarious actor from infiltrating our own build and deploy processes to distribute malicious code. There are times when our services and our personnel have access to user data, and we interact with that user data in the following ways. So first, we interact with user data as end users. I am a personal user of Gmail. I use that outside of my role as a Google software engineering manager. And of course, I might access my Gmail as an end user from inside of Google. That kind of access is obviously completely appropriate. The second way I might access user data while I'm at Google is as part of my role as a software engineer or engineering manager. You can think of the example of a Google Cloud customer who gets in touch with us, asks us to help debug something that isn't behaving as expected. And with that customer's permission, we might access some set of their customer user data as part of the debugging process. Finally, the third way is we access user data as part of a service programmatically. This is where software running in our production environment has access to user data in order to perform the functions that software is designed to perform on behalf of our customers. Our goal is to minimize the threat model presented by insider risk of inappropriate programmatic access to customer data. And we focus on that by trying to prevent a malicious insider from inappropriate access that will also prevent an external actor who has infiltrated from gaining access that's inappropriate. So to understand this, we need to understand the life of a production job at Google. At Google, our production jobs run on a system called Borg. There's actually a white paper out on that as well if you want to learn more about Borg. Production jobs at Google are required to meet certain standards in order to be deployed in our production environment and gain access to customer data. The code has to be authored, a code review is required, and the code ultimately is submitted to our repository. A build system then automates build and packaging of the code for deployment, and the artifacts created by the build system are signed. Next, the job is deployed to production by a user who's authorized to create such a deployment. That deployment goes out to a secure production identity. And finally, the job runs in production as that production identity. And it's that production identity that has authorization to access the user data. And so a lot of verification happens in that process. The verification mechanism for this is binary authorization for Borg, or I'll just call it binary authorization as we go through here. It's a deploy time enforcement of code, build, and deploy policies, those same policies that I just described. It checks the signatures of the deployed artifacts, and it enforces policies. It ensures that the code running in production has been through a code review. As one example, it has been through testing, it has been signed off by the right parties. Let me give some examples of those binary authorization checks. There are a variety of deploy time checks that take place. Some examples. Is the binary built from checked-in code? Is it built verifiably? Is the binary built from tested code? Is it built from code that was intended to be used in the deployment as part of this particular production system? As the binary authorization system asks these questions, it has various enforcement modes in order to enforce these policies. One is deploy time enforcement. So at the time that an engineer tries to deploy an artifact into production, binary authorization will simply block a job from deploying that code if it doesn't meet the policy standard. Another enforcement mode is deploy time audit. This is where we go into an audit mode where we watch the software in production, we report on violations, but we do not actually block the software from running. And the last mode is called continuous verification. This is where the binary authorization system continuously watches production and confirms that policies continue to be enforced over time. These last two enforcement modes are critical for our ability to roll out new policies. You can imagine that when a new policy comes along, we don't want to turn it off across our production fleet and possibly block a whole lot of production jobs from appropriate access. Instead, we start out in audit mode. We record where that access is going place, where that access is taking place. We verify that it's correct. And then ultimately, we turn on a continuous verification mode. Binary authorization provides several security benefits. The primary one is reduced insider risk, and it was developed to prevent any single individual from obtaining unauthorized programmatic access to user data. It makes it difficult for a single engineer or an attacker who gains an engineer's credentials to access sensitive data inappropriately and without detection. Another aspect is robust code identity. Borg jobs run in production as an identity. Those identities are used by various services, and binary authorization enables us to verify proper authorization before granting access to any data. And finally, binary authorization simplifies compliance. The continuous enforcement mode means that we know that policies are being upheld at all times. And so when a compliance audit comes along, we know a priori what policies we are in conformance with. This all sounds like a terrific system, but how do you actually adapt such a system? Well, there's a tactical approach to that. One piece of that at Google was working toward a homogeneous, containerized continuous delivery pipeline. That enabled us to have a single pipeline to look at for policy enforcement. We determined our goals and defined policies based on those requirements, and we tried to enforce those policies very early in the development cycle. This is part of a shift left mentality on security. Finally, we put a lot of consideration into determining how to onboard existing service owners. Finding a handful of service owners who would see the immediate benefits was critical to that. And we enlisted change agents in those teams and across other teams at Google before creating a Google-wide mandate for binary authorization. Having figured all of that out, we also had to figure out how to manage third-party code. This comes into play much more strongly in an open source world where most open source systems are dependent on a variety of other open source packages. At this point in the presentation, I'm going to hand off to Christy, who's going to pivot from the internal binary authorization that I just discussed to our tooling in the cloud that enables binary authorization with OSS tooling like Tekton.
Thanks, David. So you might be thinking, that seems really handy, but binary authorization for Borg is an internal system used at Google. If I wanted to use something like this, would I have to start from scratch? Fortunately, no. On Google Cloud, we have a product called Binary Authorization that is inspired by its internal counterpart. It's a deploy time security control that ensures that only trusted container images are deployed on Google Kubernetes Engine or Cloud Run. Binary authorization lets you require that images are signed by trusted authorities during the development process, and it enforces signature validation during deployment. Binary authorization has many of the same kinds of controls that we've just discussed. It supports policies such as signature-based verification and image allow listing. With the allow listing, you can designate allowed images by repository, by path, or by a specific set of image digests. And you can set these policies at the project level and at the cluster level. There's also break glass functionality with audit logging, which you can use if you need to make deployments in emergency situations. The key to making this all work is to be producing these signatures, attestations, and provenance as part of your build lifecycle. As your CI/CD platforms transform your source code into production artifacts, such as container images, something needs to be creating that trusted provenance that contains the data that binary authorization policies will act on. In this talk, we want to highlight how this is possible using Tekton and how you can use Tekton with GCP's binary authorization. As you may know, the main component of Tekton is Tekton pipelines, which execute CI/CD workloads as pipeline runs and task runs. The optional Tekton chains component integrates seamlessly with Tekton pipelines to automatically generate standardized SALSA provenance for container images, with support for more artifact types currently in progress. So, what is SALSA? It stands for Supply Chain Levels for Software Artifacts, and it defines a series of levels that anybody building software can comply with to provide increased confidence and security. It has been intentionally structured so that you can see immediate improvements in your processes without having to perfect everything at once. You can start at SALSA Level 1, which is relatively easy to achieve, and then incrementally work your way through the levels, benefiting from each upgrade as you proceed. Tekton is working toward providing users with all the features they need to comply with the SALSA levels all the way up to level 4. At the moment, Tekton users can achieve SALSA level 2, and features are in progress to provide level 3 and 4 assurances as well. And this includes some cutting-edge CD features, for example, hermetic execution. In addition to defining these levels, SALSA also defines a standard format for artifact provenance. And to generate this provenance, Tekton uses Tekton chains. Tekton chains produces SALSA provenance by observing the execution of task runs and pipeline runs. It uses type hinting to infer when artifacts are created and generates provenance for those artifacts. It can store the provenance in a variety of locations. For our purposes today, we want to highlight that it can store provenance in GCP's container analysis service via that service's Grafeus interface. This means that by installing and configuring Tekton chains alongside Tekton pipelines, you can start automatically creating provenance in GCP that can be used with binary authorization to gate deployments to GKE and Cloud Run. In the following demo, we're going to show you how you can gate deployments to GKE using images and provenance generated by Tekton. In the setup for the demo, a Tekton task run has already been used to build an image called allow, and the task run has pushed it to the artifact registry. Tekton chains was running in the cluster, so when the image was created, Tekton chains observed that this happened and generated provenance for the image in GCP's container analysis service. Meanwhile, a potentially malicious actor, David, has also built and pushed an image called deny to the same artifact registry. But instead of complying with production policies and using the Tekton cluster, he decided to build and push it from his own machine, so no provenance was generated for it. Let's see what happens when these images are used as part of GKE deployments in a cluster protected by binary authorization.
My name is David Bendori. I'm the engineering manager for the Tekton team at Google, and I'm going to give a demo today of our binary authorization offering on Google Cloud Platform, which is our externalization of binary authorization for Borg. Everything you're going to see in this demo today is available in open source. If you go over to github.com/Bendori you'll see that I have a repository there called Tekton on GCP. That repository contains scripts that can be used to set up a GCP project exactly like this one. These are the scripts that I used to set up and even run this demo. And that will enable you to set up a similar pair of clusters in a Google Cloud project and play with Tekton chains and attestations yourself. So here I'm at my command line. I've set up my GCP project already. And as you can see here, I have got 2 Docker images already pushed to my repository. The repository is named my repo. One is cleverly named allow, and the other is cleverly named deny. I used a Tekton task run to build an image called allow. That image was signed by Tekton chains, which also created an attestation attesting to the provenance of the image. In contrast, I built the deny image using a local Docker build and pushed that image to the repository. It has no associated provenance or attestation. I'm going to now create deployments for each of these on my Kubernetes cluster. One deployment for the allow image, which I will call allowed, and a second deployment for the deny image, which cleverly I will name denied. Now, when I look to see if these deployments are in place, what I find is that the allowed deployment is ready, it's up to date and available, whereas the denied deployment is not. The reason for this is binary authorization. If I look at the events on my Kubernetes cluster, I see events for pulling and pulled the allow image, whereas there's an error for setting up the denied deployment with the deny image, which says there that no attestations were found that were valid and signed by a key trusted by the attestor. Let's go have a look at that in the Google Cloud Console. So here we're in the Google Cloud Console for the same project. And if I go and look at my Kubernetes clusters, I have 2 clusters up. One is called Prod, one is called Tekton. The Tekton cluster is where I built these images using Tekton. Here's the Prod cluster. And you can see on the Prod cluster, if I scroll down to the security section, I have binary authorization enabled. Let's go look at the settings for that binary authorization. It's under the security area, cleverly named binary authorization. And when we look there, we see that we have a policy in place for this project. The policy for GKE cluster US Central 1.prod, which is our production cluster, says that we will only allow deployments of images that have been approved by all of the following attestors, and it lists the attestor that we used to attest to our image. If we go look at the workloads on the cluster itself, we see our 2 deployments here as 2 workloads. One is the allowed image, which was allowed to be deployed. The other is denied image, where you can read the error there. At the end of the error, the last line, well, starting at the penultimate line, no attestations found that were valid and signed by a key trusted by the attestor. This deny image that I tried to deploy was built by a nefarious developer in this case, who did not use our standard build chain to build it, and so did not have the attestation in place certifying that this image was deployable in our production environment, in contrast to the allow image, which was built using our standard Tekton toolchain and therefore had the needed attestation in place.
So in conclusion, implementing a deploy time enforcement check as part of Google's containerized infrastructure and CI/CD process has enabled us to verify that code and configuration we deploy meet our standards for security. This is a critical control used to limit the ability of potentially malicious insiders to run unauthorized jobs that could access user data. Adopting binary authorization for Borg has allowed Google to reduce insider risk, prevent possible attacks, and also support the uniformity of our production systems. Binary authorization in Google Cloud brings this power to GKE and Cloud Run, and you can use it with Tekton by having Tekton chains generate SALSA attestations in GCP's container analysis. To learn more about binary authorization for Borg, binary authorization on Google Cloud, and container security, check out these links. And that's all we have for you today. Thank you very much.
Thanks, David and Christy. I really enjoyed the talk and how well it broke down a complex topic and how it contained a checklist for how others could implement such controls in their own organizations. Next up, we'll hear from Jerob Kipruto and Lee Bernick, who will be diving deeper into components and features in Tekton that you can rely on to securely deliver software changes. Take it away, Jerob and Lee.
Hi, I'm Lee Bernick, and I'm here with my coworker, Jerob Kipruto. And today we're going to show you how you can use Tekton to securely bring your software changes to production. Jerob's going to explain the core features of Tekton pipelines, using it to build up a release pipeline from scratch. And I'm going to explain how you can further automate this release process with Tekton triggers by automatically firing this pipeline run whenever certain events occur on a GitHub repository. At the end, we're going to show a working demo of this release pipeline, and we're going to learn what the Tekton Robot Cat says.
Hello, my name is Jerob Kipruto, and I'm a senior software engineer at Google working on Tekton to enable developers to securely build and ship cloud-native applications. We'll explore the foundational features of Tekton pipelines in this section. In the process, we will build a release pipeline using those foundational features. Now, let's look at the building blocks of Tekton and how they fit in with Kubernetes. The first one is a step. This is the smallest unit, which runs a script based on specified inputs to produce outputs, and it creates a container in your Kubernetes cluster. Let's look at an example. In this scenario, we have a build and push step. We give it a name so we can identify what it's doing. Then we specify the container image which we want to pull. In this case, we have a Canonical project executor image. Lastly, we specify the arguments that are needed by this container. In this case, we have the Docker file, context, destination, and the digest file. Secondly, we have a task. A task is a Kubernetes custom resource of kind task, and it has to have a name so it can be reused. Therefore, this is a reusable unit of Tekton pipelines. It runs a sequence of steps based on parameters to produce outputs called results, and it's executed in a task run which creates a pod. Some of the foundational features of Tekton task include parameters, which are used to declare inputs, results, which are used to declare outputs, and workspaces, which provision volumes that you can write huge data to. Let's look at an example which uses the step that we just looked at. In this case, we also named the task Canonical build. We've specified a workspace named source code. We have a parameter called image, which we'll pull. This task will produce a result called digest. And we're using the same step that we just looked at previously. With this scenario, the task is the reusable unit that can be used in multiple pipelines, which we look at in a few minutes. To execute a task, you need to specify a task run. This task run provides the parameters and other resources that are needed by the task. In this scenario, we can see the Canonical build task, which is executed in a task run, and we specified the image. In this scenario, we have a web app demo, and we have a workspace source code, which in this scenario is an empty dir. When we run that task run, we can see an example execution of that, which ran successfully after 25 seconds. And we can see the parameter image, which is exactly what was defined in the task run. We can see a result that was produced, which is the image digest. We can see the workspace that was used. And lastly, we can see the steps that were executed. As you can notice, we actually modified the task a little bit to add one more step that checks for authentication. Lastly, we have a pipeline, which brings all of this together. A pipeline is a directed acyclic graph of tasks, which runs the tasks in parallel or in sequence. A pipeline is executed in a pipeline run, which creates multiple pods through multiple task runs. The foundational features of a pipeline include parameters, similarly to a task, that are used to declare inputs. And similarly as well, it declares results, which are used to declare outputs. And lastly, it also uses workspaces similar to tasks. I'll introduce two more features in pipelines, which include finally tasks that are used to send notifications or clean up the workspaces. This execute at the end of all the other tasks, regardless of whether it was successful or a failure. And lastly, we have a run after feature, which are used to order execution when there are no explicit resource dependencies. So resource dependency is like one task needs a result from another task, therefore we have a dependency in the graph. But then in other scenarios, you may need to order it to execute in a particular sequence. In that scenario, you can use a run after. Let's look at an example where we'll use the task that we just looked at, but we also add on more features. From the very beginning, we have a name, so we can reuse and reference this pipeline. We've named it clone, build, push, notify. We have a workspace called source code and parameters. In this scenario, we have 3 of them: image, repo URL, and the chat webhook URL. Then we also have a results image digest, which in this scenario is actually just a reference to the result of the build task result named digest. When we look at the tasks, we have 2 tasks specified here. The first one is fetch source. And you can see that it's referencing a task named git clone, which we've actually provided in the Tekton catalog. And then this task uses the output workspace, which is referencing the source code workspace from the pipeline level, and a parameter called URL, which is the repo URL. What this task does is actually fetch the source code and write it to the workspace so that future tasks or subsequent tasks can use it or execute upon it. This is exactly what happens in the next task, which is a build task, which is referencing the canonical build task that we just defined in the previous section. And here we have to pass in the image parameter from the pipeline level into this task. It also uses the workspace source code. And here you can also see that we have the run after definition, where we indicate that this task should run after the previous task fetch source. And then we have a finally section. This is a notification task that we've defined, which sends a notification to Google Chat. And it takes a parameter webhook URL and the message, which indicates what happened in the previous task. So in this case, we are sending the status whether it was successful or failure, etc. To execute this pipeline, you need to define a pipeline run, which provides the parameters and other resources that are needed by the pipeline. So in this scenario, we can see that we provide the repo URL, the image, and the chat webhook URL that are needed by the pipeline. We also provide a source code workspace that's needed. In this scenario, we have a volume claim template of 1 gigabyte, which will provision a persistent volume claim that can be used across all of these tasks. We also have task run specs that are providing the service account names to be used by the different tasks. This allows and gives users flexibility to modify execution at runtime. And this is an execution of the previous pipeline run that we looked at. We can see that it was successful after 46 seconds. We can see the parameters that were used, which are exactly what was defined in the pipeline run. We can see the result that was produced, which is an image digest that actually referenced the results from the build task run. We can see the workspace that was used, which is the source code workspace that we defined. And we can see the 3 task runs that were executed as part of this pipeline run, which are the notify, build, and fetch source task runs, which all of them were successful, making the pipeline run successful. In the next section, Lee is going to introduce Tekton triggers, which adds automation into Tekton.
Drop showed us how we can use Tekton pipelines to build up our release pipeline from the ground up. And now I'll show how we can use Tekton triggers in our example to fire this pipeline run whenever certain events occur on our repository. The first core component of Tekton triggers that we're going to be using in today's demo is called an event listener. An event listener is just a service that listens for events and fires some triggers when they occur. So on the right here, I'm showing a webhook that I set up on our GitHub repository for today's demo. And this webhook is going to be sending events to our event listener IP address. When you set up an event listener, you can optionally expose its IP address outside of the Kubernetes cluster that it's running in, and that's what I've done here. A really nice thing about Tekton triggers is this event source is super customizable. So it doesn't have to come from GitHub, doesn't have to come from a webhook. If you wanted to migrate your source control provider, you can do that without having to rewrite any of your event listener pipeline configuration. And it doesn't have to come from a Git repository at all. So you could use a cron job if you're doing nightly releases. You could use a message broker, or you could even set up this trigger to fire based on events published by Tekton itself. I talked a little bit about firing triggers, but what does that actually mean? So you can think of a trigger as a mapping between an event payload and a pipeline run or another Tekton resource that you want to create. On the left here, you can see an example of a GitHub payload from our demo. And here is an example configuration of the pipeline run that we might want to create, our release pipeline, when this event happens. And a trigger just allows you to specify how you want to turn this event into this pipeline run. In our example, I've added a filter. Because the main branch is the only one that gets released into our application, we don't really care about pushes to other branches. So I'm filtering based on some content from the message body to only the events that we care about. You can also map the event payload to pipeline run parameters. So for example, if you wanted to reuse this event listener, trigger, and pipeline run combination for a different repository and its release process, you can do that very easily with Tekton triggers. And triggers also has built-in support for validating GitHub event payloads. So you don't have to worry about events coming from other unknown sources on the internet. It allows you to validate that the events that say they're coming from GitHub are actually coming from GitHub. Let's move on to our demo and see how we can fire our release pipeline when Girop's pull request is merged. Lately, I've been working on a web app for my next big business idea, making animal noises. I want to show you what my web app can do. So I'm going to run it over here in my terminal. And let's make a request to this app and find out what noise a cow makes. My web app is pretty smart. It knows that cows go moo. But there's one feature that's missing from this app. I want to know what noise the Tekton robot cat makes. My app doesn't know yet. Luckily, Girop has been working on a feature that will teach our app what noise the Tekton robot cat makes. In today's demo, I'm going to show you how we can use Tekton to bring her changes securely to production as soon as this pull request is merged. Now that we have our GitHub webhook and our Tekton event listener set up, let's go ahead and take a look at Girop's pull request. Right now, we don't have any pipeline runs running in the Google Open Source Live namespace, as you can see in my terminal on the right. When I merge this pull request, GitHub is going to generate a push event on the main branch. And in response, our event listener is going to kick off a pipeline run in this namespace that will build and publish our web app image. Let's go ahead and merge this pull request and see what happens. As expected, there's now a running pipeline run that's busy publishing our changes. I'm going to let that run and come back to it when it's done. I've gotten a notification on Google Chat that our build has completed successfully. So let's see what happened. We can see that our pipeline run from earlier has succeeded. So I'm going to use the Tekton CLI to figure out the digest of the image that it published. And we can see the image digest right here in the pipeline run results. So I'm going to go ahead and pull this image and run it again locally and see if we can find out what noise the Tekton robot cat makes. So I'm going to Docker pull, Docker run, and let's make a request to our web app. And it turns out the Tekton robot cat says beep boop meow. So I hope this demo has inspired you to try Tekton for secure software delivery.
Now that we've looked at a demo of Tekton pipelines and Tekton triggers, you may be wondering what more you can do with Tekton. Let's look beyond the basics. You can level up your Tekton pipelines using some of these features. You can handle transient failures using retries. You can control execution time using timeouts. You can specify conditions for execution using when expressions. And lastly, you can use cluster resources efficiently using the task run compute resources. Some of the advanced features in Tekton include fan in and fan out using metrics, fetching of tasks and pipelines using remote resolution, and extending Tekton pipelines functionality using custom tasks. Some of the other Tekton projects that you may want to look at besides Tekton pipelines and triggers include chains, which you can use to secure your software supply chain, results, which you can use for long-term storage of execution outputs. In this case, we're referencing the pipeline runs and the task runs. And have the dashboard, which is the user interface for the Tekton resources. We have the catalog and the hub for sharing and discovering your Tekton resources, which makes it easy for you to get up and running quickly. And lastly, you can check out the community project to learn more about contributing to the Tekton project. Thank you.
Thanks, Jarop and Lee. It was great learning about the breadth of the features available. I kind of want to take some time and automate my entire job away using Tekton, but let's just keep it between us. Okay, next, we'll hear from Alan Gallardi and Rafael Santos from Nubank as they discuss how they scaled up their CI/CD platform using Tekton. Over to you, Alan and Rafael.
Hello, I'm Rafael now. I work at Nubank for almost 4 years now. I'm a lead software engineer at the CI/CD team, and we're going to present you how Nubank scaled its CI/CD platform. I'm here with Alan Gallardi.
Hello, people. Thank you so much for having us. My name is Alan Gallardi. I'm a staff software engineer here at Nubank. I joined the company almost 6 years ago. And let's tell you a little bit about our experience with Tekton, how we scaled up our CI/CD process to support millions of builds, and how Tekton plays a crucial role in this process. So just before jumping into the interesting parts, let's talk briefly about Nubank if you don't know us. So essentially, Nubank is a fintech, a financial institution that was born here in Brazil in 2013 with a very ambitious mission of being the most influential fintech in the world. We started out with a single product, a credit card, operating just here in Brazil. And a few years later, now we are operating in 3 different countries. We provide a wide variety of financial products. And recently, we got to the impressive mark of 7 million of customers. And let's take a look at how this accelerated growth can be reflected in our engineering numbers with Rafael.
So how that massive scale translates to engineering. Nubank has over 1,500 engineers. It does over 1,000 deploys per week, manages over 3,000 GitHub repositories. We have over 40 Kubernetes clusters. And in terms of CI/CD, we run about 2 million task runs per month and process 680,000 GitHub events per month. And this scale is not only important how big this is, but how we got there. So in this graph, you can see the number of task runs per week between October 2020 and October 2022. And you can see that in October 2020, we had less than 20,000 task runs per week. We reached a maximum on August 2022 with 500,000. And we are sitting around 400,000 and below. Before talking about these challenges of growing that fast and managing a CI/CD cluster that big, I'm going to take a step back and look at what we had before 2020 and how Nubank does CI/CD before all that. So in the past, we had an on-premise legacy CI/CD system, the GoCD, and GoCD works with a master worker model. So that was giving us a high operational burden because we had to manage over 300 EC2 instances in AWS, and we had a single point of failure on the master node. The master node not only had to orchestrate that many instances, but there's other processes very important, like providing the UI and doing backups and so on. That was leading to long queues and instabilities. We had since the instance was attached to the AWS roles, we had a poor policy segregation. We had a trade-off between having more operational burden and following the least privilege principle. And even with all that operational burden, we couldn't support all use cases for Nubank. GoCity doesn't have a good support for pull request workflows, so we started using a software as a service for that. Also, Monohypos, we had a different solution for that, and we really wanted to have a canonical approach for CI/CD. Now, Alan's going to talk a little bit about that.
Great. So back to 2019, we were struggling a lot to keep our CI/CD operations minimally functional. And it was quite clear for us that we would need to change dramatically the status quo. And we started doing this move by creating a dedicated team for managing the continuous delivery, the continuous integration delivery process inside the company. And it was definitely one of the most important decisions that we made in the past, because this enabled us to start treating CI/CD as a first-class citizen. Continuous integration and delivery plays a crucial role inside the company by enabling people to deliver software faster and safely to production. And it makes totally sense for us to treat CI/CD as a domain, as something that could be understood with a value by itself. It's quite curious because typically CI/CD or companies tend to treat CI/CD merely as a mean of achieving something else instead of being a value by itself. And not merely the CI/CD process ends up being a bunch of ugly bash scripts spread across multiple repositories, and things tend to become a mess over the time. And we decided to change this approach and to build a solid product vision over our CI/CD platform. So let's move on. And just before getting to Tekton, it's worth answering this question. Why exactly we decided to use Kubernetes? Well, we were looking for a solution that could help us to scale over time, to absorb high demands, high loads, and also to be cost efficient. The idea was having a platform that could scale to be adaptable to periods of high peaks, and also to be smart efficient enough to deal with periods of low usage. And Kubernetes came out as the natural solution for that, because Kubernetes already solves handsomely this kind of problem that we were facing. Kubernetes is the standard for containerization. It has a robust and very mature ecosystem of multiple applications around it. Kubernetes integrates nicely with Prometheus and other monitoring tools. And as I said before, we'd like to treat CI/CD as a domain, and we really like to apply the same quality, the same standards that we apply to other software products or other products inside of the company. And for sure that observability, gathering data for making more accurate decisions is part of this philosophy. And finally, Kubernetes is quite flexible. It provides custom resource definitions that we can leverage for modeling or creating abstractions that can represent our domain well. So since the beginning, we knew that we'd like to build a few abstractions on top of our CI/CD platform. Okay, so let's move on and let's get to Tekton finally, Rafael.
So we knew that we wanted to move to Kubernetes, but we didn't know exactly how. And we started to look to alternatives. And we found this presentation about Tekton and GKA, trying to show you how next generation of CI/CD looks like. And really caught our attention because it was Kubernetes native. We ran some proof of concepts, and it really solved our issues with policy segregations and really had good building blocks for us to build a very scalable platform. Of course, having new platforms doesn't mean that we're going to stop having challenges. We're going to have a bunch of challenges. And I'm going to try to show you some of those challenges, starting with garbage collection.
Let's talk about the challenge for running Tekton at massive scale. Garbage collection. We realized very quickly that accumulating a large number of objects inside a Kubernetes cluster would not be a good idea, because it puts extra pressure over the etcd and consequently over the API server. So we had a couple of incidents where due to the large number of objects inside the Kubernetes cluster, the whole system started to degrade in terms of performance. So we experienced long queues, increasing latency, and so on. So we developed a custom garbage collection mechanism for deleting completed runs. And then by doing this, we observed that the performance of the cluster improved, and this enabled us to have a more dynamic cluster in terms of scheduling a great number of simultaneous task runs. Of course, that once we start deleting things, we lose history, and history is something crucial for a CI/CD platform, not only for providing data for people that want to debug runs, but also we are in a financial area where audit process is something quite common and necessary. So having some way of having this data persisted for analyzing later was crucial for us. We developed the mechanism for persisting the data of the runs into our data lake to be consumed later. And finally, logs. Once we delete the test run, we end up deleting the underlying pod, and also the logs go away. So we created also a custom mechanism for collecting logs and sending them to a persistent storage to be served back later to our users. So and it's worth mentioning that those things were developed before the Tekton Results project came out. Okay, so let's move on. Let's talk about Parafinite Assistant. In our case, we decided to disable the Parafinite Assistant entirely, because since it forces task runs that share the same workspace to be scheduled to the same nodes in massive scale, reminding that we are talking about thousands of simultaneous runs. We observed long queues. We have some repositories with a very high churn in terms of contribution. So we decided to move to a different approach. In our case, we use a network file system, EFS, because we run our platform on AWS. And EFS, this network file system, can be mapped to a read-write many person volume. So this helps us to attach this volume dynamically to nodes without caring about doing this manually. And this helped us a lot to have a more elastic cluster. We use an external system that provisions nodes according to the resources that are assigned to test runs. And with this approach, we got to a more dynamic, more elastic cluster where nodes go up and go down according to the demands. You can see through this chart that the number of nodes in the Kubernetes cluster varies a lot according to the demands. So let's move on. Finally, high availability. It's certainly another important aspect in terms of running things in massive scale. We observed under a certain periods of high peaks that the Tekton's controller was getting extremely overloaded with a large number of keys to be processed in its work queue. And we were experiencing, again, long queues, high latency to schedule new runs. And we decided to scale up the Tekton's controller vertically and horizontally. Vertically by assigning more Google teams, more workers to consume the keys from the Tekton's work queue. And horizontally by relying on the excellent leader election support provided by Knative, where we can have multiple active replicas that will shard the keys among them, So we use this extensively. Currently, we have 5 active replicas running. This helped us a lot to deal with these challenges. So let's move on to talk about vendor limits, Rafael.
Well, with all this new platform, we removed most of the bottlenecks, but we started to reveal other bottlenecks. We started to have issues with rate limits on GitHub, and we've really built our platform around GitHub to provide feedback for our users. So that was really key for us. We also had issues with Kubernetes API server latency, TCD, and part of our network infrastructure. When you're running that many concurrent tasks, you're gonna have to provision your network accordingly. And we started to have challenges on that as well. And to address this, it was clear for us that we needed some control of how many concurrent tasks we run in our cluster. We couldn't just trigger pipeline runs every time that an event came. So we decided to implement an execution queue outside Kubernetes, and it's important that's outside Kubernetes because Kubernetes is part of the system too. So having this on, we used AWS SQS that enabled us to observe metrics on our Kubernetes and decide if you're going to run that or delay that execution. Why I built this whole framework? This framework is about scalability, but it's also about having more usability for our users. So really wanted to have autonomy for a very diverse team that we have in the bank to develop and maintain their pipelines. We wanted to have high-level abstractions and improve the development experience. We also didn't want to lose control over some canonical approaches since you have a very uniform architecture. And we've built on this abstraction to really remove the complexity of maintaining pipelines. So now I'm going to show you a bit about this platform. In this demo, I'm going to show you how to create and run workflows. We're going to use this repository that has a very simple Golang test. The first thing we need to do is to create a folder .new/workflows. This depends on the installation and it's configurable. We can create a file pr.yaml, and since we are defining a workflow manifest, we're going to start with API version workflows.dev/v1 alpha1, then the kind, metadata. Here we don't need to fill the name field. We can define only the namespace, since the name is going to be automatically generated based on the file name. Then we have the spec. The first thing I want to do is to define when this workflow is going to be triggered. We're starting with events, push, then branches. I'm going to run on all branches except main branch, since this is a PR check workflow. Now I'm going to define the tasks. We're going to define a very simple unit task. And here we can define the steps. The first step is a special step that clones the repository. Then we can run go test /. You can also define names for these steps. And now we need to define the image that we're going to use. We can define it inside the step, but we can also define a default image for all the workflow. So we can define defaults image. Here I'm going to use an internal image from ECR. Now our manifest is ready, and we can commit and push to the repository. I'm going to open a branch, git checkout, add new workflow, add new PR, commit, add new workflow, git push. Now create our pull request. We can see that we already have one check, letting us know that the workflow is all set. This means that the workflow is already configured in our cluster, and we can check with kubectl, get workflows, and we can use the label to filter by repository. This also means that all the dependencies from that workflow was also created. So, for example, we have a CRD called deploy keys that manages the SSH keys for the repository. And here we go. So now the workflow is ready to trigger in the next push. So I'm going to create an empty commit, git commit, allow empty, trigger workflow, git push. You can see that the task is already created. We can click on the details. It's waiting to start. Now it's done. You can check the details of the task here, events, results, and the rendered task spec. You can also click on any task at any step here and get the logs for that step. Here in the log, we can also enable timestamps and download the log. That's it for this demo, and thank you.
Finally, people, next steps. So currently, we are working hard for designing a consistent sharded architecture for our CI/CD platform, because even after all of those things that we mentioned over this presentation, we are still growing fast, quickly. And we are reaching to certain limits, mostly in terms of storage of etcd. We have projections telling us that we go there to those hard limits in the beginning of the next year. So we are trying to anticipate things and design a sharded architecture. Of course, the objective is having multiple clusters, sharing load, but also providing this in a seamless way for our users. Hopefully, this design will be captured somehow in our framework. We are also working for open sourcing our platform. This is something that we'd like to do soon. We strongly believe that we solved a few problems that can, that the community in general could take advantage of the things that we've built. Most likely other companies running into the same issues as we are could leverage the things that we developed in a very good way. So hopefully soon we're gonna have news about this. And finally, just to mention that recently we got closer to the Tectons community. We joined some interesting discussions about some features. Rafael joined the working group for building a workflows engine for Tecton recently. I have been working actively, contributing actively to the Tectons Result project. I think that's quite promising. Certainly, there are many features that this project can provide to help us to solve some challenges that we are facing. And hopefully, this contribution will keep going and growing over the time. Okay, people, that's it for today. Thank you so much for having us.
Thank you. If you have any questions, feel free to reach us.
Thanks, Alan and Rafael. I really enjoyed the real world numbers, and that is some really impressive scale. Lastly, we'll hear from Al Huizenga, who will discuss the core features in Tekton Pipelines V1 and exciting new features in development. Take it away, Al.
Hello, my name's Al Huizenga, and I'm the product manager at Google Cloud, responsible for Google's contributions to the Tekton project. I want to talk to you about a couple of things today. I want to sort of tell the story of Tekton, where it came from, and how it was born, and sort of where Tekton is in its life cycle. And then when I get to the end of that, I want to talk a little bit about areas of future focus for Tekton, so you can start to calibrate what sorts of things you might expect to see, and whether Tekton is an appropriate CI system for your plans. So let's start by talking about the Tekton story so far. And I wanted to start by going way back in history to 2018. And this is a very early comment from not the first, but one of the earliest commits to the Tekton Pipelines project, which is the first and still core Tekton project. It's a commit by Christy Wilson. And a couple of things are really interesting to me. She checked in this diagram, which she threw together, and it still kind of holds up. It lays out the core object model of Tekton, the pipeline and the task, the pipeline run and the task run, and the parameterization. And it's really interesting if you use Tekton now to see that the skeleton was there, that the core still holds up, and this still is a very accurate sort of representation of simply what Tekton is and what it does. There's a great spelling mistake in here for posterity, which I think is really amazing. And she's basically saying, I've been working on the strawman proposal for adding a pipeline custom resource definition. So this is all around how we are going to make pipelines and tasks run in a Kubernetes containerized environment. And there's some really smart people mentioned in this early comment. We have Dan Lorenc, who has since gone on to start a really cool company called ChainGuard. And of course, we have Christy Wilson, who still works on Tekton at Google. And actually, Christy just happened to publish a book called Grokking Continuous Delivery. So check that out. That was 4 years ago. The Linux Foundation kind of outlines what the life cycle of an open source project is. So that was like the very early proposal stage. And that's when you're sort of identifying a need out in the market, and you're sort of gathering your forces, analyzing it, and figuring out what you want to do. And then there's the incubation stage. And I think that's largely where Tekton has been. I mean, these stages bleed into each other a little bit. It's not exact, but that's roughly where Tekton has been since. And this is where you start to accumulate resources, build your community of contributors. This is a really critical stage in the project because it's kind of when the vision is cemented and people start to contribute more and more. And there's a lot of projects that just kind of lose their way in this phase. And the next one is the maturity phase. So this is when you start to see a pace of release pick up. And you actually start to see some very early adoption in production environments using the software from an early adopter cohort that is bought into the vision. And then you move into the core stage. And this is where things start to go big. You start to reach a much broader audience. The vision is sort of bought into more widely. And that's really challenging too, because the team has to maintain its focus despite all these sort of requirements and demands from this big audience of people doing very serious implementations. So as I said, Tekton has been in the incubation phase up until now. So just recently, back in October, Tekton graduated from the incubation phase to the maturity phase. And these are phases that are actually tracked by the Continuous Delivery Foundation, which is the foundation that sponsors Tekton. And this is just a quote from Andrea Fertoli, a colleague of ours who works at IBM. And he says, we've managed to mature while still maintaining sort of our core vision. And this is really important. I think one of the reasons that Tekton continues to thrive is because there's a clarity of vision to what Tekton does, and it's managed to maintain that clarity of vision as the project has accelerated. It's really focused on flexibility and standardization and decomposability. And that stands up today as well. Concurrent with that graduation to a new phase, Tekton managed to release version 1 of its core project, which is the Pipelines project. And so what does that mean? That just means that it's gotten to the point where all of the maintainers and contributors to Tekton are comfortable enough that it has sort of the core feature set, and that core feature set is stable, that they can move into the next phase, which is sort of a long-term support phase. So we're adjusting the cadence of releases to 4 a year. We're committed to not making any additional backwards incompatible changes, so you can rely on anything that you build on Tekton sort of being durable for the long term. And we've invested the time and the resources to really thoroughly test that stable core of features, so that we're highly confident that we're not going to run into unexpected bugs or instability issues. So this really is Tekton sort of announcing to the world that it's ready to build production systems on. Of course, there are lots of systems, production systems already built or being built on Tekton, but I think this is going to sort of help a wider group of people realize that Tekton is a viable solution for them. But in the meantime, we haven't stopped. In fact, things are accelerating. We're starting to see this really good cadence of ongoing new features that are hitting various stages of release. And over the course of the next, over the next year, you'll start to see some of these core capabilities and some of the supporting projects around pipelines also graduate into that V1 phase. And so that sort of that surface area of stable capabilities is going to grow and grow and grow. A few of the things that we've recently just sort of announced are really exciting and I think make a big difference. Maybe the biggest one of those is what we call internally remote resolution. And all it really means is that you can get your pipeline and your task YAML for Tekton, and you can store it in GitHub, if you like, and apply it directly from there. So rather than have the specification for those things directly inlined in your YAML, you can just refer to them where they are. Which is really handy and really supportive of kind of a GitOps flow, where you can treat your YAML as code and manage it in exactly the same way. But we've been streamlining that YAML, so reducing the need to sort of repeat things over and over again to make it less verbose and easier to express. We've got this great feature called matrices, which is just very natural support for fan out and fan in logic if you want to run a bunch of flows concurrently with different inputs and then converge the outputs. And that works really well. And then a ton of enhancements to the Tekton catalog, which is, I think, core to the idea of Tekton sort of growing and becoming a vibrant ecosystem. And we'll talk a little bit more about that later. One thing that deserves special mention, I think, is a project that has become very active over the last year or maybe 18 months, and that's Tekton Chains. And so this is the part of the Tekton fabric that's just dedicated to helping you secure your software supply chain. And the design goal for Tekton Chains is to make sure that even though we call it Tekton Chains and it's a separate project from Tekton Pipelines, the idea is that Tekton Chains just kind of exists and it's turned on by default. So if you are attempting to achieve a certain level of supply chain security in your environment, using Tekton will get you in that direction in a significant manner. And the initial implementations of Tekton Chains, and this is not in V1 status, it's still in beta status, but it should join the V1 cohort next year. The initial implementation of Chains is all about making sure that you have attestations of provenance by default for all of the builds that you're running in Tekton. So Tekton will create attestations of all the steps that are performed in your tasks, and it'll sign them, and it'll push those signed attestations to some artifact repository of your choice. And this is all really critical functionality for helping you to achieve SLSA level 2, which requires that you have hosted source control and hosted build management and signed provenance. And just in case people viewing this don't know what SLSA is, which is SLSA stands for Supply Chain Levels for Software Artifacts. And it's just basically a security framework that helps you articulate how far along the path of securing your software supply chain that you are. And on the strength of this, we've started to see Tekton become sort of the foundational continuous delivery platform in this growing ecosystem of open source tool sets, all having to do with securing software supply chain. So for example, there is a really cool new project called Fresca, which is all about demonstrating a reference implementation of tool sets and frameworks and components that can come together and help you produce software securely. And Tekton and Tekton chains are a core part of that. So that's been really exciting for us. The community continues to grow and to thrive. So originally we had that one project in one repo called Pipelines. Now there are 16 repos with different sort of supporting projects. I've mentioned chains, but there's also a project for the catalog. There's a project for the Tekton dashboard, for triggers, which is sort of the mechanism that allow you to trigger pipelines from things that happen in Git. So there's a lot for people, for maintainers and contributors to work on in the Tekton universe, and it's been really great to see. If you're looking at this graph, it sort of commits over time, going back to the very first Tekton commit. You'll see that we had kind of pandemic low or a dip in commits, and we're seeing that in some of the other open source projects that we're sort of involved with and in tune with. And now you'll see that that's starting to recover, and the pace of commit is starting to grow again, which is healthy and excellent to see. And this is really important. We've started to sort of establish a beachhead of production implementations. And in the last 6 months since I've become the product manager at Google responsible for Tekton, I spent a lot of time reaching out to people, to the maintainers and contributors, but going beyond that to people who aren't necessarily active in the community on a day-to-day or week-to-week basis, but are using Tekton to build out their continuous delivery systems for their companies. And we're starting to call these people sort of Tekton practitioners. At this stage in Tekton's life cycle, these are people who have tended to be very Kubernetes-oriented and who are looking for an approach to continuous delivery that sat naturally on top of their Kubernetes environments, and Tekton was a very natural candidate for that. And the things that they're saying are really interesting when you talk to them. Part of the appeal of Tekton definitely has to do with the fact that it's built on Kubernetes, so it's portable, and it's naturally multi-cloud. It's elastically scalable. It supports multiple teams and multiple tenants in a very natural way using namespacing. And if you take those things and combine them with the power of how Tekton expresses pipelines and tasks for continuous delivery, the fact that those things are declarative, that they're very decomposable into individual building blocks that can be shared and managed and reused, it's just a really compelling value proposition for them. And Tekton is a framework, right? So it's sort of an underlying foundation on which they can build things, but they've been very happy to do so and because they want to realize the benefits that Tekton provides for them. And these quotes here, I pulled out just some of the words that I think are really important and that we hear all the time when we talk to people who are either considering Tekton or using Tekton. It's repeatable, it's composable. They want to manage their continuous integration by convention, not just by configuration, or in other words, they want to manage it at an organizational level rather than having each individual application team manage it themselves in their own individual repos. They want sort of turnkey ability to layer on continuous delivery concepts on top of Kubernetes. And they're looking long term. They really want to build on something that's going to solve needs going out 5 or even 10 years. So they're looking for sort of a next generation technology that they perceive is at a stage in its life cycle where they can make a long bet. So that's Tekton so far. But of course, we're not done. We want to graduate to that next phase, which is the core phase. We want to start to see widespread adoption beyond that core set of early adopting Tekton practitioners. So what does that look like? Here's a big caveat. Tekton is a community, and so I'm a product manager at Google. Tekton is bigger than me, and it's certainly bigger than Google. It includes maintainers, contributors, and practitioners. And so I'm not going to present to you sort of a strategic roadmap, like a timeline with features on it, like you might expect from other roadmap presentations, because it doesn't really apply here. I think the future of Tekton is more organic, and it's more responsive to the needs of that community, which I think is really great. But that said, if you revisit Tekton's core missions and themes, and if you keep in mind who it's for, some patterns emerge, and I want to talk about those very quickly. First, like, what is Tekton's mission? It always has been to be the industry standard cloud native CI/CD platform components and ecosystem. Sometimes we call it like maybe the cloud native Jenkins, if that sort of sets the tone. And what's its vision? How will we see that this is happening? We hope to see that other CI/CD platforms start to implement Tekton conformance. In other words, they start to take on Tekton's approach to expressing pipelines and tasks so that they can realize more portability of those pipelines and tasks. And we want to see a growing ecosystem of verified publishers who are publishing catalogs of things, tasks that represent sort of common, reusable industry knowledge, so that there is a growing network effect of people who are sort of leveraging what Tekton can do. And it's important to keep in mind that Tekton is a framework. So we're really, when we design Tekton capabilities, we're really trying to keep in mind those practitioners who are building for the application developer. The application developer themselves isn't necessarily interested in Tekton or anything under the hood. They just want to build their application. So we're talking about the DevOps engineers, like the 3 people who are supporting those 400 application developers, maybe the security people who are sort of looking over their shoulder and trying to de-risk the whole thing. And increasingly, service providers who would like to use Tekton as the framework to develop their commercially supported continuous delivery service. And what do they need from us? I would say that there are generally 3 broad areas of focus as we start to chart out what it is that we need to do over the next, say, year or maybe 18 months. And so as I've been talking to them and also talking to maintainers to get a sense of where we see this going, I think these are the 3 patterns that have been emerging. So let's take them one at a time: scale, security, and interoperability. So what do we mean by scale? And we mean a physical scale, of course, just being able to really crank up the number of builds you can run daily, weekly, and monthly. We already do have a couple of implementations of Tekton that are really of astronomical scale, like really big. So this is really good. But what we haven't done is, as a maintainer team, sort of done the performance benchmarking that's required to let everybody know that this is possible, so we can start to share some hard numbers. And that will allow us to do some more documentation of scalability limits. So right now, our documentation doesn't have that sort of practical knowledge that tells you what to watch out for and where the bottlenecks might be. In terms of scale, we're also talking not just about sort of physical scalability, but the ability to manage at scale and the ability of Tekton to scale across the market. So we'd like to start to see more and more third-party catalogs from different vendors and from different parties of tasks that they would like to share back to the industry. And then another big part of scaling for us is just understanding and being able to articulate and quantify scaling. So there's a whole area of focus in Tekton that I think is still largely untapped around observability and being able to instrument your tasks in your pipeline so you know where they're running and how fast they're running or how slow they're running or where your bottlenecks might be so you can address scalability challenges as they occur. So that's the backlog. There's a couple of things we're doing now in progress. We're focusing on what we call pipelines and pipelines. And that just means the ability to embed one pipeline into another. So you have greater decomposability around your pipelines and they can be managed more easily. So you're not dealing with one big monstrous pipeline file. Some rules around what to happen around concurrency. For example, if you cancel a task or pipeline and try to rerun the same one again, and you have these sorts of collisions, how should the system handle them? And just more granular control over what happens when you have resource contention in your cluster. So you don't have unanticipated starvation of some really critical processes because you didn't have the right rule sets in place. Security, of course, really important. I talked about SALSA Level 2 in a previous slide. What we're eyeballing now is providing the capabilities to help Tekton implementers achieve SALSA Level 3. So SALSA Level 3 is all about moving beyond sort of having provenance to having non-falsifiable provenance. So what does that mean? That means that you need to be able to ensure that your build system users don't have the ability to sabotage your runs. And so for us, what we're looking at now, various parties are looking at it, is the integration of SPIF and Spire. And SPIF is really just this sort of emerging standard for articulating and managing workload identity. So what is this workload? Is it what I thought it should be? Spire is an implementation of SPIF, so it's really interesting. And we're also looking at SBOM generation. So SBOM is a software bill of materials. Everybody's talking about them now because they're really critical to making sure that you know what's in a container, right? So that you have a sort of auditable articulation of everything that's in the container images, both that you're using as your base container images to execute your build steps, and the images that you're outputting as part of your build. And so we're looking at emerging tool sets and technologies for doing this. For example, like SIFT, which is a really cool tool set that was created by Anchor. And then we're also looking at the ability to do scanning of catalog tasks. So catalog shared tasks, and we like to make sure that those tasks are trustworthy and usable in production environments. A couple of things we have in progress here are we're focusing on making sure that all of the tasks that are in the Tekton catalog are signed and verifiable so that they can be trusted and implemented in production environments. And we're looking at sort of a policy layer in Tekton that sort of allows you to articulate what to do when particular attestations are or not in place. Finally, let's talk about interoperability. I think this is really critical when practitioners start to implement Tekton. They love the core capability, they love the features and the patterns, but it has to coexist with a number of different systems, most notably Git or some flavor of Git, but there are other systems as well for sort of observability, log management, interoperability. So overall, Tekton lacks and still needs a robust eventing framework, and we're looking at Knative events as a potential way to fill that gap. That will allow us to embrace this emerging standard under the CD Foundation, just like Tekton, called CD events, which is a specification for which events different systems in the CI/CD ecosystem might pass back and forth between each other. And if all these systems speak the common language, they can do that much more effectively. And this also ties into the third thing here, which is just like notifications. So a special subclass of events maybe that are specifically about pushing notifications about things that happen to various systems, for example, Slack. And what we're working on right now is custom tasks, which is really a framework for extending the idea of a task in Tekton beyond sort of Tekton core functionality. So for example, if you want a task that isn't necessarily like a step that runs in a container, you could create a task that waits for a period of time without having to schedule a container for it, and it just sleeps and it doesn't waste any compute resources. Or maybe a task that waits for an external event to occur, or a task that executes some operation outside of the cluster and then waits for the execution of that task to complete. So all of these use cases have to do with tying sort of external systems and sort of non-Tekton patterns into your build flow. So we think actually custom tasks are going to become a really important part of allowing Tekton to thrive and become sort of an ecosystem that's easy to implement into your existing combination of systems. And the final one that I'll mention here is workflows. So workflows are a higher level and more opinionated objects, sort of above pipelines and tasks, that represent how Tekton interacts with GitHub and maybe other Git-based platforms. And we're still working out the details of what that might look like. But the idea is that if you're a Tekton practitioner, you're building stuff from scratch, but you shouldn't have to build the most common and obvious things, like making sure Tekton can respond to stuff that's happening in GitHub, like a code commit, or perhaps sending tasks and pipeline status events back to GitHub via the GitHub Checks API, so developers in GitHub can get some sense of what's going on. So workflows are basically kind of like higher level opinionated wrapper objects that will allow us to do some of those things for you, so that the onboarding experience for new Tekton practitioners is a little smoother and it's not as much of a mountain to climb. So that is just a smattering of the things that we're looking at over the course of the next 18 months or so. And it's really exciting. There's tons of things to work on at Tekton. The velocity and the collaboration that's happening in the community right now is really vibrant and exciting. If you're interested in participating in either being a maintainer or contributing in any other way, including writing documentation, which is always badly needed, that would be exciting. Go to tekton.dev. And of course, if you are in a situation where you're considering what the next generation technology for your continuous integration and continuous delivery needs are, you should go check Tekton out. That's it for me, and thank you very much.
Thanks, Al. It's amazing to hear about Tekton's version 1 journey. This is a huge accomplishment, so big thanks to you, the open source community, for getting Tekton to where it is. So just a reminder, all the content will be available on demand after the event and published on Google Open Source YouTube channel next week. The content will also be available with captions in English, Spanish, Chinese Mandarin, and Brazilian Portuguese. To access captions, click on the settings icon looking at the bottom right hand of the screen in the video player. You'll see subtitles/CC, and you can scroll and select your desired language. All right, that's a wrap. You know what that means. Maybe you don't, but I'll tell you. It's time for the after party. So go ahead and click the Watch Live button in the event's agenda page.
Today's speakers will also be joining us for some Q&A, and we will have an exciting quiz ready. We hope to see you all there, and thank you.